your data. And just from your own personal impression of your data, what the most important statement you could make about your research?
The most important statement I can make about my research is that, in retrospect, one of the things that maybe I would have looked at differently is growing my bacteria in a different state of growth. There were some vast differences between previous research and what I found. To simply state what my research is conflicting. The gram-positive should have shown a larger or greater response to these dyes. That has been the history of them. That was seen with my bacillus strains because they have been shown to be especially susceptible. That is the primary greatest statement I can say. That was the bacillus showed the greatest response of what I expected to see, and even and that is an indicator that that is an avenue of interest that you can take with treatments. There's a 37% annual crop loss. Pesticides cost $4.1 billion annually. That would be
When you examine the two dyes at different concentration, how many samples do you have for each concentration?
There were 3 samples. There were 3 trials.
3 samples. So you did it.
There were. What I did was I created 10 milliliter cultures. I inoculated into those. There were 3 trials for each dye. 3 of 0 parts per million control. 3 of 5.1 control for each dye.
What the reason you did not analyze? You get it from the table, and in my opinion, it is very important to compare the 2 dyes at different concentrations. See this one. What to prevent you from analyzing it and to tell us whether there's differences exist or not, because the number will not tell us, but the statistical analysis will.
I'm not sure if I'm understanding your question, but
What the reason there is no statistical analysis for the most important data in the research?
the individual trials.
We have 2
Okay,
concentrations for each treatment, and you have 2 treatments, the 2 dyes.
Right.
But we saw in the table, why is the data is not analyzed?
Between the 2 dyes.
Or between the 2 dyes and
It was analyzed between the two.
No, when the table showed just a number, when we mentioned there's nothing.
You're confusing the plates with the tubes.
Are you talking about the colony forming
Yes.
units?
Yes. You don't have to go through it.
Okay. I only did a qualitative analysis to indicate recovery. If I had done plates, they can be statistically analyzed. The colony forming units as an indicator of how many colonies were actually in the represented by the optical density. It was I had one. It was me and Janet, and it literally took me.
Couldn't we get the user to analyze it? I think
Yes, it took me 2 hours to do just one set of data per day, and by the time I'd get around to doing all the others, it was very time consuming.
Yeah, but all my question, I thought encourage you, this is important data, if you could analyze it with your thesis.
The colony forming units to do statistical analysis.
I commend you for your job, it is wonderful research, but the folks in Durham, if they tell you there's p-value means significant, then you spoke. P-value means probability. When you say at 5%, that means you have 95% confidence and 5% error.
Right.
But that does not, that value has to be compared against a tabulated value using the degree of freedom of your analysis.
Right.
So you need to visit that before you put it in your thesis, whether significant or not.
Okay.
Do not say p-value.
Here's the critical, the F critical?
Yes.
Okay, yes, I did not put that in my table, however, I did do the ANOVA to compare to the critical. I did do that. Dr. Rayburn? Yes.
I'm sorry, I have a statistical question as well.
Please go right ahead.
When you analyzed it, was all of it analyzed together? Because I'm having difficulty understanding there was an interaction on dye and an interaction on dose.
I did a 2-way ANOVA with replication. The 2-way ANOVA was between the dose, the 4 doses, and between the 2 dyes.
Okay, so it was all analyzed at one time?
Yes,
That's correct.
yes,
That's correct way to approach.
yes,
And you put
yes.
emphasis on the dye or on the concentration? Because you have 2 choices, like, so which the main treatment, what was it? Is the dye or the concentration?
Dye the concentration. That is what the interaction indicates. If the interaction was significant, yes.
Well, before you go too much further, there was a point I was going to make on that. What's the molecular weight of the 2 dyes?
Molecular weight of fluoxamine is 829.71 kilodalton. I am not positive of the other.
The reason I'm asking is if the molecular weights are the same, then I don't have trouble with what you do with your analysis.
Okay.
However, if the molecular weights are different, you really need to go to a millimolar comparison. Because if molecular weights are different, when you put in 10 parts per million, you put in different numbers of atoms of your dye.
Right, right. I see what you're saying.
That's all it was.
And your optical measurement for between 400 and 700, what is your actual measurement?
660 nanometers.
And that because
It's in the visible light range, however, it's toward the end of the visible light range, indicating there's deeper penetration of the dye into the cell membrane.
but that is coming from the literature or coming from your experience with the dye?
It is coming from both. The visible light range, between 400 and 700,
It's already between 390 to 770, that's not the issue. When you select a specific nanometer to measure the absorber, is there a reason you did not select 700, there's 400, there's 660?
the reason I chose 660 nanometers is because that was what was used typically in the research.
Okay, all right.
Yes,
All right.
yes.
So in recorded that the optimal absorbent at that nanometer.
It's also very similar to ambient light. I tried to keep it also simple in the idea that if a treatment were to be developed from the research, that it would be something that a layman could do. They could find a standard light source that is around 660. That does seem to have an optimal effect. Yes, Richard?
I have a question.